Blinky, blinky?
So
Yeah, just keep your mouse on that side of the screen. I think right arrow keys will work for you. Yeah, you're good.
I'm not going to have to change anything anyway since it's Ted's. Cool. Alright, everybody. Since Ted is pretty much in charge of this meeting tonight, I'm just going to do a general rundown of what's going on for the next few days / what happened today. We went to Northrop Grumman today, did a presentation to a room full of Northrop Grumman engineers, which was terrifying. I apologize, my voice is kind of cracky. I spent last night practicing for that, and then they're supposed to give a speech today, but maybe not, maybe will, maybe won't, we'll find out. But that went really, really well. They asked good questions. They pretty much at the end said, what can we do to help? Which was sort of tricky since there's not a whole lot we can ask for, but they did offer their system engineering people to come by and take a look at what we're doing. So they'll be in touch with us so we'll have possibly Sarco system engineers and Northrop Grumman engineers. So yeah, and that of course I said it when Ted's not here. He's gonna love that little update. I was like, by the way, we're changing things for Northrop Grumman. But it went really well. It was like a half-hour demonstration, presentation, and then we did Q&A, and then we had lunch with a bunch of engineers and high schoolers. Is that? Nope, that's Aaron. You're supposed to be Ted. Poor Aaron. Aaron was there. He helped out a lot. Thank you for coming, by the way. There he is. Yeah, Ted.
Oh, did I miss the speech?
No. Yep. I'm just giving you an update about the Northrop Grumman thing.
Oh yeah, how did that go?
Good. They want to help us with system engineering.
Great. I could use that.
That went really well. So they're looking forward to helping us with that. Let's see what else. Tomorrow, being Valentine's Day, the French people are going to be here filming us, apparently. They never got back to us of when they're going to be here. So if you see some random French person wandering around with a camera, that's probably looking for us. So I'm going to be on campus from 10 until whenever tomorrow and see if they actually show up and follow through with this documentary they want to make. Give me just a second with Ted. No.
Oh, okay. Cold stall for us.
Okay. I don't bring like give me 3 random objects of mass. Oh no.
But of equal mass.
Third.
Cheers. Cheers. Oh, the cups. Over there, the cups. There's only one coffee cup.
I already stole it. They're already done. You already stole things?
Thanks, Cole. Great work.
Yeah.
You already stole all the things.
Can I have my one bottle?
Wow, lots of people can't make it tonight.
I know.
Midterms and
Like
labs
class
and,
thing or something.
and now it's like a volunteer type of thing.
Wait, who has life outside of robots?
They're off the team. That's awful. So, on that note, I'm kidding. Great wrap up.
I'll just start laughing.
No, you brought Ted. You're fine. You're fine. Ted. So that's your saving factor right there. And there's Ali. Cool. More and more people keep showing up. Story time. Do I want to be on camera? I don't. So I'm gonna sit. I'm gonna sit up here. So 9-ish months ago, call it 8-9 months last summer, the team got together for a barbecue and we wanted to do a post-mortem on the robot with the sandcrawler. We wanted to meet our new advisor. We wanted to see the future of the team. Our team president was leaving, so we had to choose a new one. And we're like, all right, let's choose that. And as you can all probably guess, I got the job.
I campaigned for him.
He did. He did. And I was super excited, and I happily told all of my friends, which was super easy because like 90% of them were there at the barbecue. And they're like, we already know. So, like, yeah, we're the ones that did it, thanks. So, but the ones that weren't there, they said, congratulations, that's gonna be real hard work. And I went, yeah. But I knew they were thinking along the lines of, this is gonna be hard work because you have to design a rocker bogey, or you have to design some way to dig, you have to choose the right batteries, your robot has to be autonomous, your robot has to move more than 5 feet. Biggest part right there, and that's what they were thinking about. And to their credit, they're not wrong. Nothing about what we do is easy. All of it is hard. And I know that. But to tell you the truth, when I got the job, that's not what I was worried about. Because I knew, / know, the quality of the people that are interested in this team. And they're amazing. To quote NASA, we are mighty. So that didn't bother me. I'm like, we'll figure it out. And we did. And I'm still super impressed because we are not only farther than we've ever been before, we are doing iterations on things that I never thought possible. From the digger to the rocker bogey system, mobility, all these different things that we've never done before, and we're making great progress. The thing that worried me was the fact that I would have to choose who goes to Florida. That's what kept me up at night. I shit you not. It's a speech, I'm allowed to swear.
Yeah.
Don't look at me like that. So that's what I was worried about. Thankfully, I then realized I didn't have to do it myself. I had my team lead, and so we spent the last couple of weeks figuring out who gets to go. And I will tell you that it was never, ever easy to cross a name off that board. Because every team here, every person here, and I'll either be mobility, programming software, you should all be proud of where we are right now. I went to Northrop Grumman today, and part of the presentation was, oh, this is what the team is about, this is like what the competition is about, and the rest of it was what we're doing here and now. The things we're designing, the things we're building, and the stuff we all do in our spare time as volunteers. And I shit you not, they were honest jaw-dropping moments from these Northrop Grumman engineers. If you don't know, Northrop Grumman is the company that designed the lunar lander. So these are engineers that, these aren't some rock jockeys down playing in the gravel pit, no offense, Aaron. That's what mining engineers love to do. And geologists, I'm the one licking the rocks, so he has to pull me out of the pile. It's like, stop it, enough. But this is the real deal engineers, and they are amazed about what we do. And every one of you has deserved to be here, and the moral work you put in is amazing. So choosing who gets to go, who doesn't, is the hardest part of the year. And we did that. We sent out an announcement last week. And so at the point, it's kind of like, well, crap, I don't get to go. But I'm going to ask everyone to keep pushing forward because we are so close to having a robot that is light years beyond anything we've ever made. And it's going to be something that we can work on for years and years and years and make better and better. And we are just at that step where we can get something driving, we can get something testing, and we can get autonomy working. We can get the best mobility system, the best digger system, and we're almost there. So I know it sucks, and I know it's rough for everyone involved because Valentine's Day is tomorrow. If you do that, I don't. That shit sucks. Then we got finals. Lots of people aren't here. Not finals, midterms. Lots of people aren't here. We have the weekend. Spring break's going to be in March, and it's easy to want to say, "Cool, I'm gonna go. I'm gonna go do more interesting things." But I want you to remember that not only is some old Navy vet, me, Navy old, proud of everyone here. That Northrop Grumman, our teachers, our advisors, they're proud of what we do in our spare time. And that's something you should be proud of too. We're building something that is amazing. And we just have to push a little bit harder. So let's keep on pushing forward. We got, 4 weeks till spring break? And Ted definitely has some deadlines he wants us to meet. He's going to spend the rest of the time saying that we're all awful people. Because we messed up his Gantt chart. But I'm going to ask, it's a large ask, I know. But I'm going to ask that everyone here keep pushing forward and do the work that I know you can do. And then, when we finally actually have a moving robot, then we can relax and have some fun. With that, I'm going to give it to Ted.
Yay! And I kind of just want to add on to what Dave said and say thank you so much for all the hard work you've all put in. I know for a lot of us, this is... Not that one yet.
not the Independence Day speech?
I think that was really more for Dave.
Yeah, I couldn't find a good time to bring it in, though.
But I know for a lot of us, this has kind of turned out to be like 2 or 3 extra classes on top of what we're doing in college.
Or jobs.
Yeah, or jobs. But even though things haven't necessarily gone the way we planned initially, I think we've still learned a lot and we've made some great progress. And so this preliminary design review is kind of just going to be us kind of taking a step back, looking at what we've done so far, and kind of comparing it with the plans we set out initially and making sure that we're kind of sticking with our design goals. So, and with that, James, are you prepared to do a quick little budget review?
Yeah, for sure.
All right, oh, there's that. That's the scary part. So we don't have a whole lot of time left. But right now, James is going to come up and say some stuff.
Okay. Yeah. Well, James. What now?
Okay, so there's a lot that's been going on, like budget related, that people haven't really heard much about. So here's the kind of the behind the scenes. Can you guys see if I read over here?
Turn the light
Oh, really? You're not going to use the... Sorry.
I have no idea how to use that in decent enough time. Okay, so we thought we started with $12,000 basically. We ended up having about $10,500. Okay. Here's the weird thing. There's two different accounts that go for the team. So we have the project budget, and we also have something else called like the team budget. Let's see. Activity budget. So in these accounts, in the project budget, we currently have about $4,800, and in the activity budget, we have $6,300. This budget has already been spent for like going down to Florida, so that's like our vans budget, stuff like that. This is the possibility of what we have left for the year. I guess there's 800 left in this one. This is the possibility for what we have left for the year, but supposedly we might be sharing this budget with another team. So Pam is the accountant that we talked to at the university, and she's trying to track down just how much of this is ours. I heard back from her today, and the last word is that this is what's in our team account. So that wasn't entirely helpful, but at the moment she's trying to switch us out from this other team, so we have our own budget money that we can focus on. Hopefully there's at least a portion of this that we can use, but currently this 800 is what we're operating on. So we're trying to get budgets together for the rest of the teams so we can kind of have an estimate of what everybody needs to finish the robot. Because there's a couple things we can tweak here and there to try and get more money out of our budget, but that's kind of what we're looking at right now, is to know what every team needs, how much we need left to spend for the rest of the robot so we don't have to send something made out of plywood. Otherwise, we'll just have to keep you guys posted on the larger budget to see how much of that is ours and dream big. Does anybody have any questions?
And there's also possibly we might get a funding system. That project budget might be freed up as well, right?
Yeah, so any other additional funding we get from this point is going to funnel into this fund, but at the moment we have nobody really committed to give us any money. ASUU, depending on if we get our org sync page updated in time and what they think of our team, we can make somewhere between $3,000 and $6,000 for travel. So hopefully we'll have a few thousand coming in from that as well, but we'll try and track down some other funding sources so we can have a little bit more to spend. But so if your team lead asks you what we need for the rest of the robot to have a final finished product, help them out. That is due next Wednesday, so a week from today, we'll try to have a final estimate on how much this robot will cost. Does that sound good for everybody? Okay.
Sweet, thanks, James.
Yes, sir.
Okay. Now, just to reiterate though,
You should have the numbers in red and be like dripping blood.
yeah,
You need like a live
we're not
countdown.
that sad and desperate yet. There is still hope. Okay, so just want to reiterate the design philosophy we came up with in our first systems engineering paper. And we kind of looked at the metrics for the point system that NASA gave out and realized that to get the most amount of points, we need to achieve full autonomy, make it fairly light, and make it dig at least 1 kilogram of dirt. Well, not dirt, the gravel inside the dirt. Because we don't get that much points for mining stuff, it turns out. And now I'm going to kind of go over the system requirements I went over at the beginning of the year, and we're going to talk about what we're doing to meet these requirements. So general requirements, initially we said we wanted to collect at least 3 kilograms to kind of give us a safe buffer to work with, because we may test it out here, get 3 kilograms, then we take it to NASA and maybe they have a sparser like spacing of gravel in their BP1 than we thought, or our digger just doesn't behave in BP1 the way it does in azomite. And then the other requirement is we have to deposit it in the collection trough, obviously. We also decide the robot shall have a maximum speed of 1.2 meters per second. I believe as we kind of gone through, we figured out that the motors we bought don't turn quite as fast as we thought they would for the amount of current we're feeding them. Does that sound right, Cole?
I've never heard of that before.
Well, last time we tried spinning it, we couldn't get it spinning fast enough to go 1.2 meters per second.
At the 1 to 28 gear reduction.
Yeah, at the 1 to 28 gear reduction.
Yeah.
So the idea to fix this is, Ben, you said you were going to work on a gearbox that has half this gear ratio.
Yeah.
Okay.
I mean, we currently have all the ones at 1 to 28, so we're going to go with that.
Yeah, I
Like
figured.
the working one.
Yeah.
But for the final one, we're going to look at a 1 to 14, just half it with double the speed.
Okay. How awful is that going to be to do you think?
Not all that awful. I think that we've pretty much figured out how to design cyclical gearboxes now, which took a while.
Yeah.
But I think all three of the people on mobility are pretty comfortable with doing that, so I don't think that'll be a big deal.
Okay, cool. And if you feel like people would be better utilized, like working on the rocker bogie and chassis, we can kind of put the gearbox on the back burner because we
Yeah,
at least
yeah.
need something that moves.
I'm definitely not priority one on that.
Yeah, for sure. And then for our dimensions, this is a 5% tolerance that I put in against NASA's maximum. So we want it to be less than 1.425 meters long by 0.71 meters high and 0.71 meters wide. How are we doing on the height one?
I don't remember. I think that we're at 1.7 now, if I remember right.
1.7 meters
Or,
high?
No, not 1.7. 0.7. With moving those NEMA 23s up the way that we did.
Okay, so let me do a little bit of math. 1.05 times 0.71. So we can go up to 0.75. That's like the NASA limit.
Okay.
So, which want me to? Sure.
That's about
Yeah.
5 centimeters, right? Somewhere in there?
Yeah.
Yeah.
Yeah, I remember we were pretty much on that rim.
Yeah.
And then we knocked off the NEMA 23s plus the gearbox of the NEMA 23s. So knocked it down for a bit.
Nathan's not here tonight, is he?
As it stands right now, that we plan for the rocker bogie to be the highest part on the rover, and the way the digger is actuating, the forward linkage sticks up over the top of the chassis higher than the rocker bogie, so that might be our highest point instead, which would put us over.
Yeah, that would put us over.
Okay.
So
And
we might need to, like, depending on how far out forward the digger goes, we might need to, like, put it forward when measuring. Make it.
I mean, we did that last year. Well, I get that's the other problem is do you end up making your robot too long when you do
Yeah,
that?
depending on how, I'm not sure how wide we are right now.
Okay. So we'll need to figure that out. And also, Digger said they were talking about making their drum diameter double.
So, yeah.
We
Yeah.
have a lot of height.
So the thought right now is that the digger drum is really wide and may not have the, while if it could get down to the gravel, it could be cool. The thought is that it may not be able to get down that far. We don't know. We haven't tested that yet. We should hopefully be able to test it tonight because we might actually have torque now.
Okay.
Um,
Oh yeah, because you actually have like a real mechanical connection to the motor now.
Well, we did. It's just that connection was made on PLA and got stripped out.
Okay.
So now it's going to be nano nylon.
Okay.
But the thought is that if that doesn't work, we're going to have a design ready to go of something that looks similar, but it's going to be thinner and taller.
Okay. Do you guys have what you need to test it? In terms of azomite, gravel.
We have the part that was not working last time, so theoretically it should work all the way. We should test it tonight.
I'm thinking about like test environment wise.
Do we have Dave's box
We
of
have
dirt?
the azimite, I think.
Yeah.
Keep your box of
This
dirt.
is in the-
Cut each your box of dirt.
I don't know what's done.
Yeah.
It's definitely not 18 inches.
Yeah, it's definitely not 18 inches. Yeah, I was gonna say, do you guys need a? Do you guys want to like try and test the full depth?
We can start with what we've got, and
If
if we get
this
down to the bottom of that, then we keep going.
succeed, we should try it.
Cool. Dave, how much of a difference is there in density between azomite and BP1?
The issue isn't the density, the issue is the compaction of the material, so.
And in that case, they're about the same since they're similar grain sizes and shape.
Okay.
Density is different because science and geology board and shit, but azomite is less dense than BP1 is.
Okay. I guess we have BP1 too, so if we want to don the
Instead,
bunny
it's
suit.
also in the lab underneath the philosophy azomite, so we can add that to the depth.
From a digging perspective, the heavier, dirtier crap you can dig up, the better. Like moving through regolith or whatever is going to be pretty easy compared to just using the volleyball pit or something.
I guess I just assumed that it would offer more resistance than the azomite, but I don't know for sure. But
If, as far as resistance goes, the motor we are currently planning on using, not the one that's mounted to the prototype right now, but the one we're planning on using, isn't going to have any issues with torque.
okay.
Absolutely not.
We don't know how much our robot weighs at this point. And like I said, with our design philosophy, we need to make it as light as possible. And so far, the only thing I know we're planning on to try to reduce weight is switching our conduit for carbon fiber. Do we have any other ideas about weight reduction?
And that won't save a ton.
Yeah.
It'll save a bit.
It'll save a bit.
It won't be dropping 20 kilos off or anything.
What size of tubing are you planning on the chassis right now?
3/4 of the chassis.
3/4?
Oh, for the chassis or for the rocker board?
Chassis.
Your mom?
I can't remember what it's got on there. I want to say that's not right. I want to say it's 3 centimeters thick right now, but that was literally just spitballing. So
Okay.
it
Are
is
we using
entirely
Are
negotiable.
we using like square tube or are we using like angled?
I designed it with square tube, but it's a very, very, very rough model right now that will not reflect reality in the slightest. So
Okay.
We could reduce that tube size, and that might reduce a little bit depending on wall thickness.
Yeah.
I think,
Or if
I
we
think wall
strategically
thickness
use
is really
different
gonna be
tube sizes in different parts of the robot, it
I think
increases
that's smart too.
manufacturing
Yeah.
complexity, but it
Because
reduces
the wood
weight.
of the chassis currently is definitely heavier than an aluminum version of it.
Oh yeah.
What are the chassis like? It's got 2x4s and it's 3/4 inches, so
Yeah, it's pretty beefy.
Yeah. And so maybe what we should do is once we get everything thrown onto the plywood chassis, let's weigh it.
I can weigh each of the goosenecks and get a rough estimate for how much stuff in mobility to weigh.
That would be good. And then we also, I think the heaviest components on there right now are going to be our motors,
Yeah, for sure.
and the gearboxes on the steppers.
Yeah, those things
Yeah,
are
they're
much heavier than I would have wanted.
yeah, they're
They're
pretty
like
beefy.
a kilogram each.
Yeah, it's insane. But yeah, so once we get everything thrown together on the crappy chassis, let's weigh it and see where we're at and see what we can cut down on.
Yeah.
And remember, our goal is less than 60 kilos. Okay, this is one that we haven't really been focusing on for the prototype, and it might be good to start getting some design ideas down. And it's all about dust resistance. And so for that, the drivetrain shall be protected from BP1 dust. Ben, you kind of got that down. You've got all of our motors and gearboxes
Yeah, we make
encased.
sure that everything's fully encased and with at least one barrier of
Okay.
So that's for the drive motors and for the NEMA 23s that actuate.
Yeah, and the NEMA 23s are pretty sealed pretty good anyways, so
yeah,
I think
we're just double sealing everything basically.
So the only opening would be where the wires come out.
Yeah, so we're having wires come out, and then I hope to have be a little bit modular and have like a connector that we could like plug into those areas eventually, so that we can have fully encased electronics.
We could just like tape it.
Well,
Yeah.
because we do have those bullet connectors coming right outside the gooseneck.
Yeah.
So that will be a good connection point, and then
For
any
sure.
holes around that, just gaff tape it up as much as we can.
Yeah, I was thinking of using silicone caulking. Just make sure that nothing ever
Yeah.
gets in there ever again. It also makes it so that we can take it apart if we wanted to without having too much of a hassle.
Okay. So active dust control features. I don't think we have any plans for this at this point.
We can charge the chassis of the robot with an electric charge so it repels any dust.
There's
not-
been some talk for Digger of oscillating the drum to say kind of do with the sand
Oh, yeah, we can throw a transducer on. It's a pretty easy way to qualify that requirement.
Okay.
Just like shake it loose.
Yeah, and that's pretty easy, and we can just cannibalize the sand crawler for those parts.
Yeah.
Um,
Not doing anything else, Dave.
Yeah, the sand crawler is not going to be digging any day soon.
well, it can still drive around and dig, it just won't play music.
Yeah.
So,
Can't drive around and dig though.
and then kind of the last one in there was complete all aspects of a mining cycle without kicking up dust. One thing I kind of thought about is if we switch for those big beefy motors on our digger, I have a feeling it's going to turn a lot slower.
So the current RPM rate is about, so the current RPMs with the motor that we're going to put on, it's got a 1 to 76 gear ratio
Yeah.
on it. It's going to turn at about 33 to 36 RPM.
Oh boy.
We were hoping for more like 60, but that isn't a huge amount to gear.
So are you going to plan a gear to get like 1 turn per second?
Yeah, we're currently debating gears or belts or something like that.
Running about 3 revolutions per second.
Hmm?
At 60 RPM?
No, it's doing 30 RPM, so that's
Half a revolution per
So
second.
we're planning on doing
Uh,
essentially 3 revolutions per second.
So
no.
3 revolutions
I think
per
the thought
second.
was about more like 1.
Right.
So this is the same motor that we've had in the lab this whole time.
The
Right.
big,
Yeah,
beefy one.
Like not the giant
No.
huge one, the little silver one.
No.
We're talking
the-
about the huge one.
The
The
big
big
cake.
fat
These are the
black
big ones
one.
that we used on as drive 2 years ago. Like the big
On
black
Amy?
ones.
It has
half
at
acre,
its
so
current
they decided
gear
to
ratio, it
have
has
those
15
on.
newton meters.
So you've officially changed.
That's a lot.
The thing's
No,
not
not
changing
yet.
it right now.
Okay.
Well, we're in the process of doing design.
Make sure
Yeah,
you
how
let
heavy
electrical
is
know
that
when you
motor?
decide.
1.7 kilos
They're really plausible.
So-
with gearbox.
If I were you, find some way to do some tests to figure out like how fast we actually need to go in the dirt to be useful.
Yeah.
And I feel like if we do slower and more torque, you'll need to put like gigantic scoops on the digger so we can move more material with each pass.
If we go with gigantic and thinner, we were talking about this on Slack last night. We're going to probably go with more scoops, and I think I'm going to try to talk. We're going to talk about how many of those we're going to want.
Okay. But yeah, make sure you get your current design in the dirt first and see
Oh,
what
yeah.
it do. But yeah. And the other one I was thinking of is complete all aspects of the cycle without kicking dust. But I was thinking just like if we do end up going with a much faster drum, do we want to like put like some sort of cover plate around it so it doesn't throw dust around? We're talking about your digger. I was just saying, do we want to put like a dust cover kind of around like over the back of the digger so it doesn't kick dust up?
Yeah.
Okay. Now honestly, and this sounds insane, but we could just like make it out of cardboard because it's super light.
Forge light.
Yeah.
It's
fun
like-
story with dust mitigation. It does lose points. It's not a whole lot of points, but more importantly, it pisses off the judges, and they're the ones that get to score us inside the pit. So your team, I think it was Alaska, I'm not sure, but they had a belt digger kind of like we had last year, going at like 120 RPM like a chainsaw, digging down into the BP1, and like the entire arena fills up with BP1, and they didn't do so hot. So, because they didn't mind a whole lot, but it's also because if you piss off the guys who are giving you points, then because they're in there all day with the BP1, so it's not safe and B, it annoys them, and C, points for the competition.
Yeah.
And I've learned to take cardboard, put like a layer of duct tape over it, and the shit will never break.
There you go.
And then it's a composite material.
Yeah, that's right.
It's an advanced composite material.
Would we have to soak it in resin first, or?
You've got a fiber and a matrix.
Yeah, sure.
Yeah.
That's what. So does that mean duct tape's a composite material? So, looking at the software requirements, we got to perform a 10-minute competition round autonomously, be able to navigate to the mining arena from a random location and orientation, drive to the mining area and back to the collection trough autonomously. So, we're working on that, and the plan is using the POSIX, doing RF localization to get the bottom one or the middle one, and we kind of just have to do clever programming for the other parts. And then we're using the Z stereo camera to kind of map terrain. We're still trying to figure out how to program the autonomy system and how to give it navigation around all the awfulness that NASA will throw at us.
Or can we just go that the rocker buggy's so awesome that we can drive over whatever we want?
Yeah,
That's it.
I mean,
I thought that was like the point of the rocker boat.
that is a real possibility,
Yeah.
but
Yeah, I don't know. Do we know like the max size of things that they will put in front of us?
I don't think it was big, right?
Yeah, like rocks were about yay big, holes were about yay deep or so.
Which I feel like our rocker
I
buggy
think
should.
we'll be good.
Yeah, we should be able to handle that,
Yeah, I
but
think we should.
that's assuming we know what we're doing, and that's not
And we
usually.
don't, so.
Yeah.
I don't want to go at full speed.
Yeah.
Yeah, that's a good thing.
Handling it and balancing with the full load, which isn't going to be that much because you're only getting a couple of kilos. That's
Yeah.
a real challenge.
But it has to be a couple kilos of the gravel, and we don't know how well we're going to reject the BP1 out of our digger.
So it could end up being like 5 kilos or 1 kilo of actual.
Yeah, exactly. But yes, where testing comes in. Hooray. And then we got to dump the stuff into a collection bin, which is going to be a little interesting because we got to play with our localization system to see how accurate it is enough, and to make sure we actually end up positioning our drum over the collection bin. If it turns out it's not, we'll have to find another sensor system to detect how far we are away from the collector bin. So, yeah. And then moving on, we have to use less than 50 kilobits of data. That should be doable if we achieve autonomy.
Is that like kilobits per second, or is that like kilobits?
It's kilobits.
Alright.
You start losing points after
Yeah.
you use more than 50
Alright.
kilobits.
Is it like a significant number of points, or is it?
The way I see it is if you end up using more than 50 kilobits, you're going to end up using a lot more than 50 kilobits.
Yeah,
Because
50 kilobits actually isn't that much.
it's really not, but it's like...
It's pretty much
But,
enough
like-
to say go.
Yeah,
like
but
it-
like-
it's a go command. That's about it.
But if we have to use more than that, that probably means we're doing teleop. And we might have to find a way to program our teleop to use not much data.
Well, I think that even autonomy may use more than 50 kilobits.
Why would it, though?
Feedback data.
Are we going to get feedback data, or are we just going to say go dig the hole?
We can talk about this later, but I'd rather not be in a black box.
Okay, well...
Well, we have the NASA footage.
That costs data.
Oh.
They actually charge data on that. It's a flat fee, but we do need to take that into consideration.
Yeah, and for the cameras, it's like 250 kilobits per second.
Yeah.
So we start losing points.
You lose instantly.
Yeah.
So
Well, it's not like... It's like per second after 250 kilobits per second, isn't it?
well, yeah, so if you use the camera for 1 second, you're already over your 50 kilobits.
Yeah, exactly. But I was just saying, like, I think the data rules are different for the cameras.
Yeah, it is, and we'll have to take that into consideration.
Okay. And the robot shall accept a start and stop command to begin or end autonomous operation. And that was kind of one of the weird rules in there, is like, if you really wanted, you had the ability to switch your robot over to a manual operation in the middle of the competition run.
Partial autonomy.
Yeah, and so if you can tell that it's about to do something awful, you can switch off autonomy and start driving around with the joystick. So we'll have to implement that still.
Never mind.
Yeah.
If you
Different
hear screams
conversation.
outside, turn it off.
So the other thing is not using the competition walls and achieving autonomy.
Mm-hmm.
That's the other one we still got to figure out. So we need to talk to our Z people if they ever show up and have them get to work on doing that stuff. And we can't use a compass or GPS. Good thing we don't have any of those. Electrical requirements. We need to have a commercial off-the-shelf kill switch at least 40 millimeters in diameter. Do we have one of those yet?
It's in the list.
Okay, on the purchase list?
Yeah.
The one that will be sent out next Wednesday. Yes.
Okay. The switch shall not cut power to the data logging device. We just have to make sure we put that in the right spot, I guess. The switch shall disconnect the batteries from the whole robot, and I'm guessing that's part of the design for the power distribution board and a relay in there, right?
Yeah, something like that.
Okay. And are we using the power meter from last year? Is that the plan?
What's up?
Yeah,
What's up?
What's up?
Yeah.
Cool. Yeah. And the other thing is, we had testing metrics made at the beginning of the year when we thought we'd have something to test. But I can't find them anywhere, so the systems team is going to write some new ones for y'all to start testing the robot with. And then next, do you want to do some stuff?
I mean, for this part, I was gonna kind of continue the whole testing idea, and instead of like performance testing, rather, how can we test to make sure that we don't break in the middle of competition, or like kind of testing on mission critical components. So I kind of just wanted to, I guess, brainstorm a little bit, like what do we need to run? Like I know this year we would like to, move a little bit, so that's probably like wheels are probably like a mission critical thing. So I know we had like some concerns about gearboxes melting. So is that fixed, or is that still a concern?
I'm not super concerned about it.
All right. So
If
as long
we need, we'll print them out of a higher temp material.
okay.
There's some type of lubrication we can throw in there that won't mess with it too much, like a silicone or something
I
like
think we're going to do
Yeah.
lithium grease.
Lithium, that'll work.
All right. And then also we were talking about like sensors for a little bit, and I know the Z is like visual based, so will there be like a problem with like if we're increasing the drum size, that if we can't map our surroundings, then we can't really do autonomy very well?
The
So-
camera's set in the front of the robot and taking out the back.
Okay.
So, for
That's-
that specific reason.
Yeah, that's gonna be interesting. Then I don't know. Does anyone else have like any?
The batteries shall not turn off this year.
Even when they catch fire, they shall not turn off.
That's right.
All right. And then also, I was kind of like thinking about this, and also like another concern maybe is now that we're like moving the wheels more like with the rocker bogie. Is there like a possibility of moving cables that they could possibly disconnect at all, or are we?
We've had some concerns with the bullet connectors because apparently they're kind of brittle, so we need to work with that to make them more robust because
Okay.
some of them snap off.
Snap off sometimes.
Yeah, so we need to make them more robust so they don't do that.
Hot
And
Something.
heat shrink.
hot glue?
Heat
Yeah.
shrink
hot glue's
definitely.
Like hot glue would be good to resistance to it.
Yeah.
And silicone.
We need a team hot glue gun.
We definitely need
Like a
one.
DeWalt
Purchase list.
battery powered one.
Oh, those ones are great.
I know.
But yeah, I think the key with that is just stress relief on all of our wires.
Well,
Okay, that'd be cool.
Like even just
we
plugging it,
can probably
unplugging
get
it.
those.
But yeah, so just electrical team plan on strain relief everywhere. So don't make any wires tight where they connect, I guess.
Yeah, assume that that connection is going to break at least once or twice. And you can shorten it up if you need.
You can also put that spiral braid around that bit that comes out.
We'll have
That'll help.
lots of like casing and slack and do our best.
But that gives me another idea for the programming team. Do we want to take actions on error conditions? Like if for some reason we lose a pull on one of our brushless motors, do we want to detect it and stop the robot?
That's going to require looking into the O drive to see if it can detect a failure.
I mean, you could just pull one of the wires off
From what I've seen,
already.
it doesn't have that functionality.
Yeah. Well,
really.
also pulling it off, you are going to get sparking on that. Just so you guys know.
Okay.
Sounds like fun.
Anything
I
else?
mean, that's about all I kind of came up with, but like, if anyone else has any other, like,
I guess the thing we're kind of worried about is like, what are the biggest points of failure on our robot? What are the mission critical things that we think might break?
And contingency operation.
Yeah.
We'll put that
Like
to
if
the
we're in
testers.
Florida and we got to go on in 10 minutes, what are the things we're going to have to deal with?
Secondary axle for the digger drum.
Yes.
It's going to be in a lot of different types of forces and braking, braking policies, I guess. I don't know. But we'll need an extra one because we're pushing down at the same time we're spinning it, and so it's gonna snap. So one or two of those would be a good idea.
Okay.
Make sure our motors are easily accessible
And
and
it-
won't murder themselves.
And as we're going through this thing, I should mention this at the beginning, but like, and you're thinking of stuff we need to get done or make changes, try to take mental notes or physical notes.
Preferably physical notes.
Imaginary notes are not acceptable.
What about contact sense?
These plans have been in school for so long.
But any other points of failure that we can think of?
We should probably make sure that we have extra goosenecks and everything like that. All of the goosenecks and everything are identical. So if we have one or two extras, that if something happens to something, we can just slap on a new one.
Okay.
We should also bring the steel conduit to Florida in case we break some
We
fiber.
fully plan on making a second bigger rank.
Yeah.
Yeah, maybe just doubles of all of our 3D printed parts, maybe triples
Yeah.
for the gearboxes.
It'd be nice if this robot could be like a Formula One car where you can just pop things out,
Modular everything.
like have it be extremely modular, make things easy to access. It's going to be harder to design, but like the motor lesson from last year, how the motor you had to take off the belt to get into the motor, even then you only had a couple inches behind the motor. That's kind of hard to do when you're in the pit.
I think
So-
a couple inches is being quite generous.
Well,
Just a couple centimeters.
A couple inches, and I showed my fingers like this, so use the physical.
Couple of millimeters.
Yeah, millimeters. So modular everything. IKEA robot.
And it looks like we've been doing that so far. I
Yeah.
think we have a lot of good wiring plans set up so that if we need to hot swap something, we can pretty easily.
Yep.
I mean, like, do we have enough time, kind of like, to really make everything super modular, or is that kind of like a?
I mean, we're kind of already doing it with
Yeah.
electrical. I mean, and mechanical. It's like stuff that's bolted that should be bolted is bolted.
And with the separate teams operating on their separate systems, that itself leads to modularity
Yeah.
because they're not being integrated immediately. They know that they have to be
Yeah.
modular.
Yeah, and the only thing we haven't really talked about is the digger motor and that making that kind of modular. So just make sure you like plan on some poor electrical engineer having to dig in there at some point.
The entire digger system is pretty modular as it is already.
Okay.
It's
The
been
way
designed that way.
the way the housing's being designed is you can pretty much remove 4 bolts and take off the entire motor cover.
Okay.
Sounds good.
Cool. Do you have anything else, Josh?
Not really.
But I do.
Oh.
I'm guessing people have CAD models and whatnot, and I would really like that to put into the systems engineering paper.
Yeah, that'd be
And
good.
then I'm going to be sending out a Word doc on like what each of, just asking like 4 or 5 basic questions on like what you guys did, why you did it, how it integrates with the robot, and then any problems you face and how you overcome it. So expect that by like Friday-ish, and preferably like the more you can throw on it, the better, because I'm gonna cut it down to like 2
Cool. Thanks, Brian.
No.
Oh,
Yay.
Okay. So, and I just kind of want to go over like,
It's there.
okay, as long as I don't touch that.
That.
So I just kind of want to go over like, kind of what I've been hearing from the different teams about what kind of their next steps are. And so, starting with mechanical, I guess we're making a new rocker bogie design, and we want to make a chassis out of aluminum. And aluminium. It's spelled aluminum.
This isn't gonna be
But and digger changes. It sounds like you guys might be switching to a different motor. Might be.
Oh, new motor is pretty much guaranteed at this point because we seriously doubt that even if the motor that we have right now gets proper torque, like in terms of just ability to dig, we're still not sure on that, and so
This motor was never meant to be the final motor.
yeah.
So we're probably
That's
gonna
true.
do something.
Okay. The other thing that might be worth looking into is that big beefy motor you guys are thinking about using.
We have plans for that already. It's a lot less handshaky than it sounds. We do have plans.
I know, I was just gonna say that. I bet that motor is sort of similar to our stepper motors, that I bet if you could figure out where we got that motor from, you could find that same motor with different gear ratios.
That motor was purchased from Fidgets.
Okay. That's not gonna be needed. We have the ability to gear it up as we need to because of the way it's gonna be built.
Are you gonna do a belt drive?
Yep.
Okay. And you've got plans to like tension it and junk?
Yep.
Okay.
We can move. The motor mount will be such that, or the way the motor will be mounted, such that you can like move it back, and it will have slots for tensioning.
Okay. And if you do that, are you still gonna double your drum diameter?
Probably
Yet to be seen.
that's gonna be testing first.
Okay, cool. What else? Electrical, all I've got for you guys is plans to assemble a new power distribution board and get the e-stop switch. Is there anything else I'm forgetting?
Put it in the robot. I don't know. That sounds about right.
Okay. And run wires to stuff.
Run wires to stuff.
Okay. Programming, we're gonna do autonomy.
simple.
Yeah, exactly. It'll be easy.
Make it do itself.
And kind of the sub-items on that. We basically haven't gotten any autonomy programming done right now, so we have to make sure we get our localization system put together and figure out how to do cost mapping with the Z in a point cloud. Then that's it. Any questions?
Actually, one thing. So for Z, we actually do have the whole point cloud thing being able to report to DOS.
Oh, sweet.
So I think we put a document on either GitHub or one of our Google Drives, kind of sharing all that stuff.
Okay, awesome. Do we know how to like do cost map stuff with that yet?
That's where you need to feed it into RTAB.
Yeah.
We have we can feed into our tab. We got the cost now.
Our tab is a cost map, isn't it?
Yeah. So.
Yeah, am I right on that, Cole?
Yes, RTAB generates a cost map.
Okay.
And I think it does navigation as well, or route planning.
So we got to feed into our tab and create a like a map pretty much.
Okay.
What's around it, so.
You said you got it to feed into our tab? Oh, score. If I were you though, dig into the NASA rules and see what it says about using the walls. And
FAQ. FAQ will have more information on the rules.
And also, because you may need to throw some extra code in there to filter the walls out of your point cloud, which is an adventure on its own. But
You got anything else?
any other questions?
How close is the robot like ready to be wired up? I guess.
Ben?
We should have all the back by 3 days every time you say that.
Well,
We have
okay, just-
100% of our pieces. So
fair enough.
we have people with time, it will be done.
Okay.
I think we're gonna put the other side on tomorrow, and we have pubs now, so I think pretty much tomorrow.
What time are you guys meeting tomorrow?
After tomorrow.
6 to 7.
So like after our meeting. Cool.
Yeah, I mean-
6 till as long as it fucking takes.
Put wheels on things.
Have something nice for the French people.
Yeah.
What?
Have something nice for the French.
Everyone loves the fun.
As a reminder, so I don't think this is going out to the general channel yet. Mechanical team, both Digger and Mobility, we're moving all of our stuff to the new lab on Saturday. That's going to be at 11 till probably won't take more than an hour or two. That's going to be the chassis, the parts that we can take away from mechanical, so probably most of the brushless motors, the goosenecks, that type of stuff. They have workspaces they can put in there. It's harder to access because you need either me, Ted, Tina, or Cole to get into there, but we'll be at the work sessions anyways.
And
Sorry.
most of the mechanical doesn't have access to the clinic lab anyway, so
One of the reasons why, this is another announcement, there's a lot of us, as you can see, and putting all of us in a clinic bothers some of the other teams in the clinic. So because of that, we're going to start moving over to our own personal labs so don't get in anyone's way. We're not in trouble, just if we get out of there, it leaves more room for more teams to do cool stuff.
We now use power tools inside.
Did you sign the SOPs?
Yeah.
Yes.
Sweet.
Anything else I got? Keep an eye open on Slack because of the French people tomorrow. I wonder how many people have said that online. Keep an eye because of the French people. But that might be happening, might not. If I might scream for people to come, look like they're busy on a robot, that type of stuff. It's probably going to rain and snow, so you won't see us outside if they show up at all. But just keep an eye generally for that. I think that's all I got.
Are we moving the prototype over there on Saturday?
Yes.
Okay, so we need to move electrical and programming over, or else we don't have a robot to work on.
Well, is there a work session on Saturday?
Just
So-
so we can move our stuff later. but-
Yeah. It'd be nice if we could inventory everything as we move it. I will try to get that system set up in the lab. I will try to be there on Saturday to help with that. Just because knowing what we have and where it was maybe last seen 6 months ago is really going to help us. So.
Yeah, knowing what's ours and what is not ours would be really cool.
As Ben mentioned, it's kind of a busy time of year. We got midterms coming up, even though it's not a midterm. As a reminder, school, family, sickness, that comes first. Take care of yourselves. But do remember what I started the meeting off with. You're all appreciated. Thank you all for being here, and let's make something cool. So unless anyone else has anything, any other admin's got anything?
I think that's it.
Go have some fun.
Thanks, everybody.